simultaneous equations. The basic idea of a simultaneous equation, solving it. First step, we want to eliminate one of the variables, then solve for the other variable, one we're left with, and then substitute back in and work out what the eliminated variable is. That's the basic idea, known as the elimination method. Let's do a reasonably simple one. 2x plus 3y equals 21, and 5x plus 2y equals 3. We need to eliminate a variable. So we make the coefficients the same. I'm going to multiply the first one by 2 and the second one by 3, because I've decided to eliminate the y's. Of course, you could have just as easily chosen to eliminate the x's. Doesn't really matter, it's up to you. Coefficients are the same, so just a subtraction will get me a nice little equation. 11x is negative 33. I have solved for the other variable, x equals negative 3. So we substitute back in, and we can work out what y is. Now, reality on this sort of question, I probably don't show my substitution step on this. I probably just look at it and go, oh, well, minus 3, bang, that's what y is. But I need to write my answer down. There it is. Therefore, x equals negative 3, y equals 9. It needs to be very clear what your answer is. I can't leave it where, oh, x is over there, y is way over here, and then whoever's looking at my solution, they've got to search out the answer. Oh, there's x, oh, there's y, terrific. No, make it easy. What nice, neat final line. Now, I used x and y on purpose, because you may recall this is also how we find the intersection of two lines, for instance, in coordinate geometry. The answer here is not a coordinate, so you don't write it as a coordinate. This just happens to be, I'm using the pronumeral x and the pronumeral y. Okay, if it is a coordinate geometry question, and you're finding the point of intersection, fair enough, then you would write it as a coordinate. That would answer the question. Let's try this one. Can't use the elimination method here, because I've actually got 4 pronumerals there. Because x squared is different to x, and y squared is different to y. Okay, they're not like terms. You can't add y and y squared and things like that. So we have to do it differently, and that's where a substitution comes in a lot easier. I'm going to make y the subject in the first one. Again, you could have made x the subject. Why did I choose y? That's a lot of y's. Probably because the coefficient's 1, so I don't have to do a division. Probably the only reason. So we end up with y equals 14 minus 2x. Then I will substitute it into the other one. And let's work this one out. We end up with a quadratic. Oh, it'd be nice if 3 went into everything there. Hang on. 5 and 6. What's 5 and 6? Ah, damn, that means 3 doesn't go into it. I was hoping 3 would go into everything there, but it doesn't. So 3x minus 41, x minus 5. So one's a nice answer, x equals 5. The other one, a bit ugly. 41 on 3, well, it is what it is. Still a number. Now we have to substitute back in. And when we do that, we get 2 possibilities. Now, there's no way in the world I'm going to leave my answer like that. Because leaving it like that actually implies there are 4 solutions. Because I could match any x with any y and so on. So I need to be very clear about my solution. No. There's only 2 possible solutions. When x is 5, y will be 4. And when x is 41 on 3, y is minus 40 on 3. And if you think of it graphically, the top one's a straight line. Ooh, do you know what the second one is? That's interesting, actually. Do you know what the second one is? If it was a plus, it would be a circle. It's actually a hyperbola. What we call a rectangular hyperbola. So like that one, but it's been rotated 45 degrees. So the vertices of the hyperbola are actually on the x-axis. It's sort of like, imagine a circle exploding. So x squared plus y squared equals a constant gives you a circle. When you change it to minus, that circle explodes out, and so now it's going like that instead of a circle. So sort of way of thinking about it. But anyway, what I'm getting to is logically a straight line, that particular straight line must only cut it in 2 places, and why we're getting 2 solutions. All right, let's have some real fun. You know, what? Mere mortals. 2 pronumerals. Anytime you've got the same number of equations, different equations, one can't be a multiple of the other, as the number of pronumerals, it should be possible to work out what the pronumerals are. Just need the same. So what am I going to do with this one? First of all, I'm going to create 2 new equations. by eliminating the same variable from both equations. So I'm going to multiply the first one by 2. And I'm not going to do anything to the second one because now the x's will eliminate. I have this new equation which must be true. 7y minus 6z is minus 38. I will now grab another pair and eliminate x from that as well. So I'm now going to multiply the first one by 4. Eliminate the x's. I now have this equation, 3y minus z is negative 10. That also must be true. I now have 2 true equations and 2 pronumerals, our traditional simultaneous equation question. So now I'm going to solve them simultaneously. I've made them both 6z or negative 6z. So I'm going to eliminate the z's and I end up with y is negative 2. I can now work backwards and calculate the others. Subbing into the first one, there we go, z must be 4. Subbing into one of the first ones, I can't remember whether it's 1, 2 or 3, but we get x is equal to 3. There is my solution. X equals 3, y equals negative 2, and z equals 4. What we have just done is found the point of intersection of 3 lines in a 3-dimensional space. That's essentially what we've just done. Exciting, hey? Okay, 1G we will add to our list.